Let's see structures in C programming. So what is an structure? Is basically it is used for handling a group of logically related data. So what do I mean by that? Suppose you have some data where you have some student name, some roll number and marks, which means for a student you want to maintain his marks, roll number and maybe student name. Now, these are the three things you want to maintain, and these three things are not of the same type, which means it could be a character pointer, maybe, right? It could be integer, it could again be integer. So, these are the three things which are not of the same type. Now, can you store these three things in an array? Obviously not. Why? Because this is some other type, this is some other type, and this is some other type. So, if you are declaring some array for integer array, then you will say everything should be of integer type. If you are declaring some array of a character pointer type, then you will say everything should be of character pointer type. But you want something from character pointer type and you want something else from integer type. For that purpose, we have something called as struct in C programming. So in this case, like in the struct, what we do, we declare something called some box in which we can basically have three or any number of different type of variables. So here in this case, we just have three variables. One is int, right? Another one is also int. Another one is character pointer. So you can basically declare a memory and you can pack that those three variables in a box, and that box is called struct, right? So just see the definition. It is used for handling a group of logically related data items such that student name, roll number and marks. And second point is real part, and like second example is real part and complex part of a complex number is one other example. Why? Because these are also related. So it helps in organizing complex data in a more meaningful way. So let's just see some example. So that's the idea. Suppose I want to describe a box which is having three different fields. One is width, another one is length, another one is height. Now these three different fields are logically related and I want to pack these three fields into one box. So what I can do, I can declare one struct, right? So this is just a theoretical definition. We will we will go to see that how it is syntactically defined. So this is the syntax. Suppose that you want to declare a struct for a box, so you will say struct and the name of the struct. This could be box or something else. It is up to the user. So we can say box, box1, box2, or anything we would like to name, right? And in this struct we are defining three fields which are all of them are integer type. That is perfectly fine. All of them could be of different type also. So first is integer width, and another one is length, which is also integer. Another one is height, which is also integer. So that is perfectly fine. Now this is a struct. Similarly, I want to define another struct which is just having one variable. That is also fine. I am saying that this struct name is circle, CIRC. This is the struct name, and the field is the radius, and which is having a double type, which is perfectly fine, because in struct you can have just one field, multiple fields, or any in case of multiple fields, any number of types are also possible. So these are the two structs. And now suppose I want to define a variable name of the struct, then what I will be doing, I will be writing struct box. So this is just a name of the struct, just like an integer. So see, if I want to define an integer, what do? I write int and then b, right? So I will say that b is an integer. Similarly, here I do have two structs. I cannot just say that struct b. Why? Because which struct you are talking about. If I just say struct b, then compiler will get confused that which struct you are talking about. Either you are talking about this struct or this struct. So that is why, to avoid any kind of ambiguity, what we are saying, that you need to write the name of the struct also. Struct box, right? This is the complete name. This complete name is analogous to writing int. Either you write like the way you are writing int and then int b, this whole declaration is saying that b is an integer type. Similarly, this struct box b is saying that this small b is a struct box type. Similarly, this whole thing is just like an integer, double, or float, right? So you are saying that c is struct circle type. That's how you can define a variable called b or c of box type or circle type, right? Now, suppose that there is some other struct which is struct book bank. in this struct I do have different kind of variables. One is title, which itself is an array. That is perfectly fine, because inside an struct you can have any type of variable. So this is a character array, this is also a character array, this is integer, this is float. So this is one other struct, and suppose I want to define some variable of this struct. I will say struct book bank. So this is just like an int, right? This is just like an int, and then variable name book 1, book 2, book 3, like that. So this is how we can define the structs, right? Now just notice here that this semicolon is very easy to forget, so do not forget this semicolon. Once you define some struct, you also need to put the semicolon. Okay, this is the struct name, and this is how we are defining the variables. This is the whole thing is treating like an integer. Okay, now there are multiple declarations or multiple methods to define structs. One method that I just shown you is that you write the struct prototype, which is struct employee and all of this, and then you are writing struct employee even. So it means that this whole thing is treating like an integer or some data type, which is int, float or something, and then even and e2 are your variable names. But there is a method too, which says that you can also define these even e2 variable names along with the definition or the prototype, which means you can write even e2 in this definition itself, even e2 here. So these two methods are same. So okay, now you may say that that method 1 is good or method 2 is good. For me method 1 is actually better, and I will just say that do not trust me, because today I am liking the method 1, tomorrow I might like method 2, right? So basically it depends on person to person. Like today I am saying that method 1 is good, but do not trust me. Maybe tomorrow I may say that method 2 is good. So it depends on person to person which way you are writing, you are liking to write, right? Either you can write in this way or you can write it this way. Both are perfectly fine. So this way is actually explicitly saying that okay, struct employee is one type and even e2 are two variables. This way method 2 is just a compact way, but that is also fine, right? Okay. Now there is one more keyword which is called typedef. It is very important when it comes to struct. Although it is not much related to struct, but it is very important when it comes to struct. Let's just see what does this mean. So suppose you have some type, maybe some integer, some unsigned character, some float or something, and you want to give a different name to that type. Maybe you want to say that okay, whenever you are writing dollars, it should be treated as int. So you can say that typedef int dollars. So typedef is a way in C programming to give a name to a custom type, which means you can say that typedef whatever is your type, maybe int, unsigned char or whatever is your type, and then you can give a new name to that type, right? So if I'm saying typedef int dollars, typedef unsigned char bytes, and then I'm saying dollars $d, this is perfectly fine. Why? Because this dollars is nothing but int, right? Instead of this dollars you can say int, because you have defined typedef int, right? Similarly, instead of this byte, okay, this is bytes, right? Either you can say byte or bytes, does not matter. So basically instead of this byte you can say that this should be replaced by unsigned char. So once you have these two lines, you can say that D is of type int and B and C is of type unsigned char, right? Now let me ask you one simple question. Suppose if I write typedef suppose float, and then I say, let's suppose I say that fzt, anything, okay, any random name, and then I'm saying fzt a, then what is the type of this a? Tell me, type of a. What is the type of a? You will say that since you have defined a typedef float to fzt, then you will be saying that this fzt is basically treating just like a float. So you will say type of a is a float. Very easy, right? So this is how typedef is working. Now a natural question could be that why we are actually using typedef, because you know, like whenever I'm writing fzt, it is actually treating like a float. So better to write float, right? Float is even more readable, right? So these user defined terms like fzt and these things may not be much readable, but float is more readable. Similarly, int is more readable than dollars, and unsigned char is more readable than byte, right? So why we are having typedef if that is not helping us? So you will see the usage of typedef in the struct. Actually, in the struct case, generally these names are quite big, right? This struct employee, these names are quite big because we need to write two things, struct and then space and then name. So generally these names are quite big, so we use typedef in case of struct more often. Let's just see a typedef use in case of struct. Suppose I have one struct. I hope the definition is fine to everyone. Why? Because this is the similar definition we have been using earlier. So this is the way to define a struct, then struct name and the variables whatever we have. Either you can have array, you can have integer, you can have float, you can have anything inside this struct. So there is a struct that is having 1, 2, 3, 4 variables, right? And 3 of them are array, which are fine, and fourth one is integer, which is perfectly fine, right? Now you have one struct, and now you know that how to define a variable using this struct. How? You can just write struct bk, and then maybe let's suppose you want to define some variable which is having books or book1, right? Suppose this is one variable you want to define, and this is one of the perfectly legal way that is allowed, there is no problem. But there is a typedef that will make something like more readable or something like more easy. Why? Because using this typedef you do not need to write multiple words. You can say typedef struct bk. So struct bk is just like your int, right? This is just like your int. You will say typedef struct bk, which is just like int, and then books, which means that whenever you are writing books, it will be treated as struct bk only, right? So you can say books, book1, book2. It is perfectly fine. It is actually a way of saying that struct bk. So instead of books, you can just treat it like struct bk book1, book2, right? Why? Because you have typedef this books. See, in the earlier example we have typedef this float to fgt. So whenever you are writing fgt, it is just like a float, right? Similarly here we have typedef this dollars to be int. So whenever you are writing dollars, it is just like an int. Similarly, whenever you are writing byte, it was just like an unsigned char, right? Similarly here, whenever you are writing books, it is just like a struct bk. So that is how you can typedef any struct, which is like I hope very intuitive, right? Now there is one more way to typedef. See, earlier way we have seen there were two ways to declare a struct, and one is this and another one was a compact way. In the compact way we were writing the variable names here only, right? This is perfectly fine. Like if we know the variable name here only, we can write here. Similarly, in case of typedef also, there is a compact way of writing the typedef. So one way is that you define a struct here and then you typedef, and then you can declare the variables. So these are the 3 steps. You can narrow down these 3 steps in just 2 steps. How? You can write typedef in the definition of struct itself. You can say typedef struct, and then you can omit this bk, or you can write this bk. Actually does not matter to me. You can write this bk, you can omit this bk, does not matter. I will tell you that if you are writing, you are not writing, then what are the benefits and disadvantage, I will tell you. So suppose I am writing, not writing, does not matter for this particular explanation. Suppose it does not matter to me, then I am saying typedef struct, and then I am saying books. So this is a compact way where I am saying that whenever this books is written, then it should be treated as the whole thing, which means it should be treated as this struct. So you can write books and then book1, book2 are these 2 variables. So either you can write in this way or you can write in this way, both are perfectly fine. Suppose you are writing this bk, then what will happen? If you are writing this bk, then you are basically giving one more facility to you. Basically you are saying that you can either write books or you have the struct bk also. You have struct bk also, right? You can either write books or you can also write book3, something like this. Okay, this is also fine, this is also fine if you're writing bk. If you're not writing bk, then struct bk obviously does not make any sense, that then it will not be fine. So if you're writing bk, then these 2 are allowed. If you're not writing bk, then only this is allowed. Anyway, like these are just syntax. Okay, there is no much explanation to it, but you need to just remember this syntax. Like if you are writing a typedef, then you can just write the typedef variable here, and you can use that variable later. Okay, if you're writing the typedef here only. Otherwise you can write the typedef later. Okay, both are perfectly fine. Now let's see how to access a struct member using operator which is a dot operator. Okay, suppose there is a struct which is rec, and I want to access its member. There are 2 members, one is one array, another one is a long I, right? long I means if I'm omitting some data type, which means by default it is integer. Long I means long int I. Now suppose I want to assign some value to this I. First, what I need to do, I need to define a variable of that struct type, which is, let's suppose, r1. Okay, this will define memory. This will give a memory, which means I'm having one long, okay, long I, and then I will be having one array a of 4 integers, right? This is an array a of 4 integers. So there are two variables that I have. And what is this struct name? This struct name is r1, right? I hope the diagram is clear to everyone. There is a struct name which is r1, and r1 has got some memory because of this line. Now tell me, because of this line, do I am I assigning any memory? Then answer is no. This is just a declaration, like this should be the case whenever you are having any variable of type rec. But whenever you are actually assigning the variable which is r1 or r2 or any other variable name, then in that case you will be having the memory in the in the memory layout, right? So basically, whenever you are writing some variable name, then only you are having the memory. So I hope this diagram is clear, where you are having one variable r1, which is a struct type variable, and inside this variable or inside this memory, there are two variables which are one is your integer array, another one is your long integer I, right? There are two variables, and these two variables will be conjugative in memory. So I will tell you about the memory layout of the struct in later class, but for now just understand that these will be conjugative in the memory. Okay, so one is integer array, which is a4, and another one is long integer I. So instead of writing it horizontally, I generally write in case of struct, I generally write it on top of each other. So you can prefer any way, there is no problem. Either you can write on top of each other or you can write horizontally, does not matter. But whenever I will move to the linked list, in case of linked list, I will be writing it again horizontally. So you can write it in any way, like you can write your all variables in the horizontal way. Let's suppose there are three variables a, b, c, then you can say, okay, in the struct there are three variables a, b, c in the horizontal way, or you can say a, b, c like that. Okay, whatever way you are preferring is perfectly fine. Okay, but in the memory there will be conjugative memory. I will tell you little more details about the struct memory in the future class. For now, just understand that it will be a conjugative memory. Okay, so suppose this is an array a4 and this is a long int I. Now if I'm writing r1 dot I equal to 10, it means that I'm accessing, okay, this is a dot operator which is used to access the struct member. Okay, I is a struct member and I can access this member using dot operator, right? So I can access this member using dot operator, and if I'm saying equal to 10, which means it will get assigned the value of 10. That's how I can access the member of the struct. Now tell me, if I want to access this member, then how I will be accessing? I can simply say r1 dot a, right? r1 dot a, and then if I want to say a0, then I can say r1 dot a0 equal to 1. Then it means, suppose this is a0, a1, a2, right? a0, a1, a2, a3, then it will be 1. And suppose if I want to say r1 dot a2 equal to 10, then this will get assigned the value of 10. That's how I can assign the values of the struct variables. Now I hope this is clear, that how to define a struct, right, and how to access a variable of the struct. So these two things should be clear. Now let's see this program and let's see how it is printing and what it is printing. So there I have defined one struct which is struct book, which is having three variables, name, price and page, right? These three variables are of different type. Okay, does not matter to me, it could be of same type, it could be of different types. Now this struct book b1 is basically a variable b1, right? Why? Because this struct book is whole thing, this whole thing is treated like an integer or something, I mean some data type. So this whole thing is some data type, and then this is a variable, this is a variable name. So it means what? This thing will do what? This will create a memory of three variables in a box, right? I'm writing these three variables on top of each other. You can write horizontally, does not matter. So first one is name, another one is price, another one is pages, right? These are the three variables. Now what I can do, I can write I can assign the values just like in the similar way. So basically we can write the first value here, second value here, and the third value here. So b means this value will get the value of b, this value will get the value of 130.0, this value will get the value of 550. So these are the three values I'm assigning. And what is the name of this struct? Name of this struct is b1, right? Now if I'm printing b1.name, it is very easy. Can you guess it? Yes, this is b. Now what about b1.price? It is also easy, which is 130.0. And what about b1.pages? It will be 550. So this is how I'm printing the values of this struct, right? So there are two things that we have learned, that how to declare one struct, how to give the memory to the struct, and how to assign the values, how to print the values. These are the 2-3 small things that we have learned in this video. Yes, thank you.